Welcome back. Today we're going over classifying triangles. Now we're going to use some of the information that we learned in the last few lessons, and as well including some new information. So first off, triangles are named by three angles. Angles can be named two different ways. So if we look at this triangle here, we have triangle ABC. This triangle, if we're going to name angle A, this angle right here, which is 90 degrees, I could go ahead and name that by following this triangle from the outside edges here, BAC or CAB. So those would be my two naming conventions for this angle here. And you'll notice that the middle angle, if we're talking about A, it has to stay in the middle here for our letterings. It's CAB or BAC, and we're just following that naming convention. That middle letter tells us what the angle is. So if we were to label angle B in two different ways, if I want it to be angle B, then I could start with ABC, or I could start with CBA, and that's what I would list for angle B. Angle C, I would go ahead and start, since C is needing to be the middle, I could say ACB or BCA, and that would be for this angle right here, the degrees of that angle. Now, in addition to that, the sum of three angles in a triangle is 180 degrees. So the total amount here is always 180. So this angle plus this angle here plus that angle there will equal 180 degrees. And then also with that, using information on the triangle, you can set up an equation to figure that out. And that equation usually consists of angle 1 plus angle 2 plus angle 3, and that would equal 180 degrees. In addition to that, side lengths of the triangle are really important. So the side lengths of the triangle, they correspond with the angle measure of the opposite side. Now this might take a little bit to think about, but it says here specifically triangle ABC, it's shown, and it says their side AB corresponds with which angle? Well, if I look at the angle here, side AB, and it says the opposite side corresponds with that. So that one would actually correspond with side C, because the opposite of this angle right here, or sorry, this side would be the angle C. So if we just take that information and say, okay, the opposite of this, there's only one side that's opposite because it's touching this line segment here and that line segment there. And then I could go and do the same thing if I were to go on other sides. If I were to look at this angle right here, well, I'm already touching those two sides, so this one would have to be the opposite for angle A. And so we could go around and do that. So if I have the side BC, the corresponding angle, well, the side BC is right here. The opposite angle then would be angle A. And then the next one, CA, so angle CA, the opposite of that is actually angle B. And then the smallest angle, this is kind of a unique thing and kind of neat that this happens, but the smallest angle will always be opposite of the shortest side. So of these three sides here, this side is the shortest, BC, which means angle A will be the smallest amount of degrees. The largest angle will be opposite of the longest side, which in this case, the longest side here is AC, which means B will be the largest angle in degrees. And then a side is congruent to another side if they have equal lengths. That's a fancy word again for equal. If the sides are equal, if two sides are equal, then their lengths are going to be equal as well as their angle measures. And then lastly, triangles can be classified according to their side length and measure angle. So we say what type of triangle it is by what the sides are doing and then what the angle measures are doing. So we have different types of classifications here. We have classifications based off of the side lengths. So these are fancy names to tell us what type of triangle. Just like we use colors to describe what things look like, we use triangle names to describe what type of triangle it is based off of the side, and then also based off of the angle length, or sorry, the angle measure. So the side length here, equilateral, an equilateral triangle looks something like this, and in order for it to be equilateral, all sides have to be equal. And that's what this little mark here, these are marks of congruency. So you have to put a mark there to say that this one mark is equal to that one mark and equal to that one mark. If there was 2 marks here, then all of them would have 2 marks. Or if this was 2 marks and those were 1, that means they're not congruent or not equal. So an equilateral triangle have all equal sides. So if we say that it's equilateral, we know that every length is the exact same. So this could be 7, 7, and 7, or 10, 10, and 10. That would make it an equilateral triangle. Isosceles. Isosceles is 2 sides are equal and 2 base angles are equal. So these 2 sides right here are congruent. Notice this one doesn't have a mark, or if it did have, say, 2 marks, it's not congruent with those 2 there. And so that would make this an isosceles because there are 2 sides that are equal, and these bottom 2 angles that are on the same sides as those, the same sides as the sides and the base, they are also equal. Then we go to scalene. Scalene, no sides are equal, which means we don't really know much about anything other than the side lengths are not the same, and that means all the angles inside will be different as well. Types of triangles, we already know what acute is as an angle, we know what right is as an angle, and we know what obtuse is as an angle. So we just take those angles and we turn them into triangles. So if it is an acute triangle, that means there are 3 sides that are acute. Now, it doesn't have to be equilateral, but every equilateral triangle is acute. There are some acute triangles that are not equilateral because we can have 3 different angles here and not the same angle and still all be acute. Now a right triangle, there's only one type of triangle that is a right triangle, and that's with a 90-degree angle in one of the corners here. Doesn't matter which one it is, but one of them, if it is right, then we call it a right triangle. Same thing for obtuse. If there is one angle that is greater than 90 degrees, then you will have an obtuse triangle. So taking these triangles up here, we have 4 separate triangles. Based off of the information that's up here, we're going to find some stuff. So very first, we're going to find the side that corresponds to angle MNO. So if I come over here to MNO, the side that corresponds to that is this side right here. It's the exact opposite of it. So I'm going to go ahead and say side MO. And then the next one, if I look for the side that corresponds with angle TUS, so I come over here and find angle TUS, the side that corresponds with that is this opposite side here. That's the exact opposite, so that'd be the line TS or ST. And so I do that. So I have line, and it looks like I already jumped ahead on that one. But I have line TS. Now I want you to notice something. The first and the last letter in this angle are the exact same first and last letter here. The first and last letter here are the exact same. So the corresponding side, they actually have the exact same endpoints. That's why they're the corresponding side. So this is an endpoint M and O, and then T and S, and those are the endpoints that make up this line segment here. So that means I could even, without going up to this triangle here, I could look at this and say, oh, it's angle VXW. That means it has to be the line segment VW in order for it to be the corresponding side. And then going on further, it says which angle will be the smallest triangle for PQR. Well, the smallest triangle, it corresponds with the shortest side. And it looks like to me that this is the shortest side. So the smallest angle will be angle P in that triangle. And in this case, we would label it RPQ or QPR. And the largest one in MNO, that one's going to be the 90-degree angle because this one is the longest side. So I would say angle NOM or angle MON. Both would be the same. And then how can angle MON be classified? That angle is a right angle because angle MON forms a 90-degree angle. So we call that a right angle. Alright, finishing up with this, there's a couple of pieces that we need to know, and remember that every triangle has 180 degrees inside of it, so when we're finding a missing angle, in this case angle B, we need to know what that missing amount is to make 180 degrees. So we would go ahead and set up an equation, and in that equation we would take the three angles here, we would add them together and set it equal to 180 and then solve for x. So I go ahead and combine like terms, and then I subtract the 113 from both sides, and I get x equals 113. So I have 113 degrees for angle B. Now in this one, we want to find the measure of angle F. So angle F here is some amount of degrees that we don't know, and I take the 3 degrees that I have, the 90 degrees, 45 degrees, and x, and I add them together. And that's going to be equal to 180. Now my next step would be to combine like terms, which means 90 plus 45 gives me 135. And my last step, I subtract 135 from both sides, and that would give me x equals 45. So we know that this right here is a right triangle, and it's actually a right isosceles triangle because there's 2 degrees that are the same, which means these lengths are the exact same as well. The last one here, we're going to find the measure of angle HIG. So we have angle HIG. This angle right here, we're missing it. We want to know what it is. So I go ahead and put the information there and say, okay, x, and there's 3 separate angles now. So I can go ahead and add those 3 together to get 180. And then I would combine like terms to get x plus 109 equals 180. I then subtract 109 from both sides, and I get x equals 71. Okay, moving on, we have this next one. It says here we have this triangle JHL, and it has an angle HLJ, which measures 65 degrees, and angle ALJH, which measures 50 degrees. We want to draw a sketch. So I've included a sketch right here, just a triangle with the JHL. And then we need to determine the missing angle. Well, first off, it tells us that HLJ is 65 degrees. So HLJ, this angle right here, is 65 degrees. So I can go ahead and just get rid of that and then say 65 degrees. And then it also tells us that LJH, so LJH, this one right here, we already know those degrees are 50 degrees. So I would go ahead and just say that's 50 degrees, which means we are finding this missing one up here. So I put all 3 together and add them to get 180. I combine like terms, the 65 degrees and 50 degrees, and I get x plus 115 equals 180. And then I subtract 115 from both sides. So I subtract 115, and I get x is equal to 65 degrees. Which, again, this would make it an isosceles triangle. And it would be an acute isosceles triangle because all the degrees are less than 90 degrees, and there are two angles that are the same, which means there are 2 sides that are exactly the same length. Alright, last but not least, we have 3 more where we're classifying by side, angle, and then finding the degrees. So if I were classifying this by the sides, you'll notice that the 3 sides are exactly the same size, so we call that equilateral. And then inside the angles here, if the 3 sides are the exact same length and we attach them together, that means that all 3 angles here are going to be the exact same, and they're all going to be less than 90 degrees. So we call that an acute triangle. So we have an equilateral acute triangle, and if all 3 are the exact same, I have to have 3 equal degrees to equal 180, and if I divide 180 by 3, I'm going to get 60 degrees. On this next one, because the sides here, it doesn't look like there's any sides that are the same, we would call that scalene, and then we would go ahead and add the 3 angles together to find out the degree for x, but we already know that it's an obtuse angle because that's bigger than 90 degrees. So I go ahead and add my 3 sides together, and when I go through there, I get x equals 28 degrees, which 28 degrees, there's no other degrees in here that are the same, so it is a scalene obtuse triangle. Last but not least, the sides here, there are no equal sides, so that is a scalene triangle. And it is a right triangle because this is 90 degrees. So I go ahead and say right. And then this one, if this is a 90-degree angle, then I have to have these add up to 90. So 57 plus 33 equals 90. So I know that that's going to be 33 degrees. Alright, I hope this was helpful for you. And if you have any questions or anything else you need help with, let me know. Have a great day.